Hello, I'm Fran Wally, and I'm making this presentation on behalf of my co-authors, Rich Farrell, Gazalieza, Lyle Cowell, and John Hurd. Together, we've been working on a project to revise the crop nutrient uptake and removal guidelines for Western Canada. Our project is about halfway done, and so the data that I'm going to share today should be viewed as preliminary. So why are we interested in these revisions? And it helps to look back on where the guidelines sort of came from. And this is a document that I had in my office for many years. I've handed out many copies over the years to students. And of course, these were the Western Canada Fertilizer Association original estimates of nutrient uptake and removal. And so it provided general estimates of uptake and removal of the macronutrients based on typical nutrient concentrations and yields for Western Canadian crops. And they tell us that nutrient concentrations can vary with yield, so they're giving us the heads up that there's going to be some range in that data. But they provided a general estimate of sort of an average yield for each of the crops, and then the uptake, total uptake, as well as what's removed from the seed when the seed is harvested. Importantly, this was a revised document in 1992. That lets us know that that data was likely collected during the 80s. And of course, with changes in breeding and new genetics as well as management, we've got significant changes in farming practices in Western Canada. In 2001, CFI released an update, and here we see that the nutrients are reported in ranges, the uptake and removal. But actually, if you look at the data, this is the same data as that earlier document, but it's based on that 1992 version, plus or minus 10%, and the yield estimates remain unchanged. Since then, there's been a number of calculators that are available online, or you can download them as apps to your phone. This is a nice one. It allows you to adjust the yield, and as you toggle over and adjust the yield, the nutrient removal rates are adjusted at the same time. Interestingly, they point out that the nutrient removal coefficients are derived from the IPNI nutrient removal calculator. And they also say nutrient removal values may vary regionally depending on growing conditions. And the advice is to use locally available data whenever possible. When you look at the IPNI website and data, turns out that that data is actually collected globally, and it's still great information, but it isn't regionally specific. And the data might not even have been collected on the same continent, as Western Canada. So the need is there. We collected samples in 2020, and our goal was to collect 100 samples of each of 14 different crops. And we collected them from Manitoba, Saskatchewan, and Alberta, sort of proportionally representing the acreage of each crop in each of the provinces. We didn't meet our goals for some crops like mustard and dry bean as an example, and this reflects in part the lower or limited acreage of those crops in 2020. When we collected the seed, we were collecting information on the variety, as well as the legal land location, the yield, and the nutrients applied per acre. And we were avoiding any sort of fields that might give us anomalous results. So for instance, fields manured in the past 3 years. The seed samples were sent to the U of S, and we analyzed them for NPKs as well as micronutrients, copper, boron, and zinc. I want to take a moment to thank the agronomists that helped collect those samples in 2020. Without your help, we just wouldn't have been able to put this data together. So starting with seed yield, the CFI estimates are the red lines. The yields are presented using these box plots. The box itself encompasses 50% of the data, with a median value being the line across the middle of the box. The further 25% of the data is in the whiskers, so 25% above and 25% below, to include 100% of the data within those whiskers and box. There are some outliers, and those are the black diamonds. The little box inside the larger box is actually the mean value. So we can look at both the median and the mean. So when we look at the CFI estimates from that original data set, we see that yields indeed have increased with time, particularly for crops like canola, corn, interestingly, spring wheat. By the way, the crops are in alphabetical order, so you can quickly locate your crop of interest. When we look at nutrient removal, the red line again is giving us the CFI removal range estimates. And we can see that in some cases, the CFI estimates back from 2001 for faba bean are right on. And they're pretty good for canola too, but they're certainly not capturing the full range of variation in nutrient uptake. In other instances, the CFI estimates underestimate the actual removal that we saw with the 2020 crop. And I wanted to point out, there was the statement that nutrient concentrations can vary with yield. When we look at barley nitrogen removal in 2020, we're certainly seeing lots of variation in the data, but it's not necessarily related to increasing yields, for instance. There is a suggestion that at those lower yields, the nutrient removal, and this is on a pounds of nitrogen per bushel produced, might be less. And so we're hoping that as we increase our data set, we'll get a better sense of the impact of yield on the nutrient removal. Answering the question, does the first bushel that is produced remove the same as the last bushel that's produced? In terms of phosphorus removal, in some instances, good estimates from CFI, and in some instances, actually, those earlier estimates overestimated actual phosphorus removal. But in many cases, the estimates are underestimating phosphorus removal. Looking at potassium, similarly, we see where potassium removal is, with some crops, lentil and spring wheat, overestimated, and in others, underestimated. Sulfur removal is really dominated by that really high removal by mustard, but we still see instances where the CFI estimates are overestimating what's actually being removed with our 2020 crops, and in some crops, an underestimation of removal. Looking at the micronutrients, we don't have CFI estimates to compare to, but we do see a tremendous amount of variability with micronutrient removal, and that both the variability as well as actual median values really differ between the different crops. For all of the micronutrients, we're also going to be looking into the literature and the gray literature to make sure we've got a really robust data set. Boron, we also saw lots of variability, many outliers here, and soybeans a real standout crop as it turns out in terms of boron removal relative to other crops. So again, a real need to get a really robust data set. Zinc, also a lot of variability and different median values with the different crops. Faba beans standing out as a big user of zinc. So, preliminary observations. New genetics and management practices have increased yield expectations. Those N removal estimates were not bad, those earlier CFI estimates, maybe exceptions with lentil and spring wheat, but certainly the existing phosphorus, potassium, and sulfur guidelines both over and underestimate actual removal and really are in need of revision. Across the board, the existing guidelines really underestimate the range in nutrient removal. And finally, the micronutrient removal estimates are new. And so we're looking forward to really developing a really good and data set so we get a good understanding of micronutrient removal from all of the different crops. So plans for 2022, it's going to be our big second year of collection, same 14 crops. We need 100 samples per crop. We're also going to be collecting seed and straw samples, total biomass, pre-harvest samples to determine total uptake estimates. To do that, we need access to commercial fields to collect 1 meter squared samples. We're doing that by hand, so minimal disturbance, but we need your help. We need your help to identify the fields. Of course, we'd love it if you would help us collect those samples. But I've provided a QR code here, and that will take you to additional information if you would like to join us on collecting some of these samples and identifying fields that we can access. I want to thank our funding agencies, a number of grower groups, as well as the Western Grains Research Foundation. So we're very grateful for the support that we've received for this project. And finally, thank you to you. And again, there's that QR code if you are willing and able to help us identify fields where we can go in and get those biomass samples in the coming growing season. So thank you.